Hello, everyone. I'm Aditya Vikram Singh. My research title was Do Language Models Have Common Sense? And I worked on it alongside Megan under the guidance of my PhD mentor, Lorraine. So, some of the objectives of our research project was evaluating whether pre trained models would answer commonsensical questions really well. In this scenario, pre trained models would be text generative models that are already trained on some large corpora of text. And common sense questions would be questions like, what are the top 10 things that people do when they wake up? And we examined some common sense questions from the Family Feud data bank, which is actually a game show where you have these commonsensical questions being asked. And this data set was actually introduced in one of the research papers that we were reading as part of our literature review. And we evaluated one of the state-of-the-art models, the GPT-2 large model, for the performance of a generic pre-trained model on the data bank. And some of the steps we took to experiment was generating a ranked list of answers for each common sense question. And to achieve that, we tried 3 different models. We tried the fine-tuned model, which is basically a model that has some specific information about the data set, in this case, the Family Feud data set. And we also considered zero-shot generation, which is a blind attempt at answering the question, given like just what they know previously and no clue about the data from the data set. And then we tried one-shot generation, which is like we gave them one sample, like one question answer pair from the data set, and tried to understand how the model would perform given that information on our desired question. We also tried to evaluate each of these generated list of answers with the ground truth answers. And we used 2 criteria to achieve these. We attempted to use exact matches, which is like word-to-word matching. It does not consider for semantic similarity, however. So that is why we considered word net similarity, which is basically given this huge network of semantically similar words, we could easily understand like, okay, brushing their teeth versus cleaning their teeth, they're both like semantically similar and mean the same thing. And from both of these steps, we tried to determine the inferences using the evaluation metrics, which were typically like maximum incorrect answers and maximum correct answers. And what were the inferences we drew from these? We basically like came up with 2 major inferences. We understood that transformer-based language models provided like really good zero-shot performance, given that they are not being provided with any data specific to the data set. But we also understood that a confounding factor was that extrapolating surface cues and annotation artifacts could be the reason we're getting this performance and not actually the model performing some form of natural language reasoning. These surface cues could be something like if I ask, what are the top 10 things people do when they wake up? And a sentence somewhere in the corpora says that one of the things that the people do is brush their teeth. Over here, we could be using natural language reasoning, but instead it's actually just using it as a surface cue, saying that, okay, this is a sentence, so this might just fit in. We also analyzed the fact that there was a little bit of, in fact, it was this very steep descent in the performance when we considered one-shot evaluations, which was understandable because the question answer pair we were supplying might have been not very relevant to our desired question. And we also saw that there was a better performance on the fine-tuned model, which made sense because fine-tuned model would be more knowledgeable about the data set. And the overall conclusion was that state-of-the-art models did not generalize well for common sense questions without fine-tuning. Again, some of the learning outcomes that like really benefited me was that I developed some familiarity with transformer-based language models that are relevant to both natural language processing and information retrieval. I also improved my proficiency with Python, the machine learning tasks, through using the Hugging Face API, which is the API we use for calling the transformers, for creating the models, and for evaluating it as well. And overall, it also like bolstered my confidence in working on research, focusing on topics that are very foreign to me or things that I am not very comfortable with. And I think it was a great experience learning from my PhD mentor about how to do literature review and how to sort of present my findings to other people who are also doing the research. And working alongside my peer also sort of like provided that sort of the right amount of comfort so that I know that I'm not alone in this journey. And I think it was a really beneficial learning outcome that I became more confident in my approach to research. So some of the future objectives of this research, we definitely wanted to encourage researchers to operate with different evaluation design choices. So our evaluation design was like generate some rank list of answers and evaluate it based on two metrics. But I think a possible scope of expansion would be to actually incorporate more evaluation metrics, maybe evaluate more evaluation criteria, maybe evaluate some different kinds of sampling techniques for the one shot or for the K-shot generation policies. We also wanted to create a sort of framework for standardized evaluation protocol, which is like going back to what I said earlier, sort of a standardized way to approach, evaluating these pre-trained generative models. Because they're pre-trained, we cannot say that they're like, specifically performing well on a good data set. So we might want to expand our data sets, maybe evaluate it on multiple data sets, and maybe also consider like how the rank list form of answers compares to a set of answers or other forms of question answering results. We also want to run the question answer generations on dedicated clusters instead of our local machines or on like a smaller cluster on Google Colab, because that will allow us to do it with high samples, which indirectly means that we'll have more training done and probably better performance. And at the same time, it will also be faster and probably last for longer session durations. Therefore, we will be able to set even more higher samples and even more higher epochs. And I think that culminates my presentation on my research topic. And I just wanted to express my sincere gratitude to both the professor and all my peers for like providing this platform for me to display what I can, achieve given the conducive environment. And yeah, thank you so much.